Okay, so this is a standard calculus question where you're supposed to find the local extreme of a polynomial. Now, it's a cubic. So actually, your cubic is always going to look like this, unless it looks like this. The other options are you could have the max, min, and the point of inflection can converge, and you could just have one flat point here, or you could converge and just get like an up slant. Okay, so there's some variations, but basically this is what's going to happen, right? So those are the options. We have that in the back of our head. It says find the local extremes of this function. So that means you're going to be looking for a max and a min. And a point of inflection is not considered an extreme. If it said find all the critical points, then it's a little more ambiguous because it depends on the author. Anyway, it says find the absolute extreme over the interval. So they're going to have to consider any extrema that are local, and then you also have to find what the endpoints are, collect all that up in a chart, and then go from there. Okay, so let's do it. So take the derivative. And you say, wait a minute, there's a 6 that I just don't need for the next step. Aha. This guy factors. We don't have to use the quadratic formula. Good. All right. So f prime equals 0 at x is equal to 2 and negative 1. So you already know that it's this kind of situation. Okay? All right. We need to know what f value is at 2 and negative 1 and negative 2 and 3, and that will be enough information. Now, it's also easy to calculate f of 0, so let's go ahead and do that because it's super easy. Now, you can just pull up your calculator and type all this in. I'm not going to do that. You guys know how to do that. But at x is equal to negative 2, we get negative 3. At x equals negative 1, we get 8. At 1, well, I mean, if you want to calculate f of 1 just to include it, you get negative 12. F of 2 is equal to negative 19, and f of 3 is equal to negative 8. Again, this guy, this f of 1 and f of 0, these guys are optional, but they're useful. Okay, so then we can go ahead and plot this guy. There's two options. You could just make this curve and then figure out where the points are on it. But let's go ahead and do it this formal way. All right, so if we're going up to as much as plus and minus 20. So let's say this is negative 20 and this is 20. And we're going 0, 1, 2, 3, 0, 1, 2, 3 in the other direction. Okay, but we're actually only going to negative 2. So we only have to go up to this point. And we can get rid of the negative 3 point. There we go. So we're going to include all those points in our graph. Okay, f of 0 is 1. So where's 1 going to be? If this is 10, this is 5. So it's just going to be right around here. F of 1 is negative 12, so it's going to be down around here. F of 2 is negative 19. It's going to be down around here. F of 3 is negative 8. It's going to be up kind of right around, I don't know, here. Yep, okay, so negative 1 is going to be about 8. Negative 2 is going to be negative 3. But negative 1 is 8. Negative 2 is negative 3, so just about here. And negative, oh, 3, 1, 2. Yep, I made way too many points. There we go. There we go. That's all we need. And we just kind of connect the dots. We already knew that x is 2 and negative 1 are the maxes and mins, so that should not be a surprise. I'm going to graph this thing. Alright, so we sketched it, and we want, it says, did we do everything it said? find the local extremes, you can say local extrema, and they're actually the global extrema. And then you would say max, min, -1, 8, and the min is 2, -19. And it turns out that those are also, which are also the absolute extrema. And why does that? Because if we had, I'm going to make this light green so you can see, if we had gone further, then we could get a global max here and a global min there. But it's just because of where it was cut. It turns out that because we cut this cubic close to where all the fun stuff was happening, we cut off all those tails, then the local max ends up being the global max. Okay?